Emily. Sorry I missed you on the Zoom call today. I hung around for a little bit, but you didn't pop on, so I figured either you were busy or maybe forgot. I'd like to have that Zoom meeting just kind of be a standing every Wednesday at 9 a.m. appointment, unless something comes up on my end or your end and we communicate that ahead of time. I'll always plan to be there. So instead today what I did was I pulled up your most recent quiz because it looks like the couple that you've done since our last meeting you did pretty well on. So let's just chat about this one real quick. I did have it opened and this shouldn't take me but a couple of minutes. So the first question that you missed asked which table represented a linear function. So when a table shows a linear function, let me just kind of draw a fake little table here. When a table shows that it's a linear function, we've got our x's and y's. Whatever the values are in the x's, they're going to change by the same number, and the y's also have to change by the same number. Now, the number on the left and the number on the right do not have to be the same. So maybe we're just going to add 1 every time here. So as you get from the first value to the second value, you add 1, and the second to the third, we add 1, and the third to the fourth, we add 1. On the other side, maybe we're subtracting 2 every time. Okay, it doesn't matter what the change is between the left and the right side, but the change in each side has to be constant. And so the table that's correct here, you can see we're adding 1 as we go from 3 to 4, 4 to 5, and 5 to 6. On the right side under the y's, we're subtracting 1 from 6 to 5, 5 to 4, and 4 to 3. If we focus in on the table that you selected, these are going up by 1 on the left, but on the right hand side we go up 1, so there's plus 1, but here we go plus 2, and so now that change is no longer constant, so it will not be a straight line when we graph it. Okay, question 8 says that Jordana drew the function below, which statement correctly explains if whether or not her function is linear. So first let's talk about the word linear itself. Hopefully in the word linear you can see line. And so when a function is linear, it means that the graph of that function is going to be a straight line. So when we look at the first two options, this is not a linear function. This line has a curve to it. Something that's linear will look like this, could look like this. We could go this direction, could be really steep, and these are all freehand, so they don't all look perfectly straight. Those are all examples of linear functions because they are straight lines. So now the two options we have left are that it's linear because it has it's not linear because it has a constant rate of change, or it's not linear because it does not have a constant rate of change. If a function has a constant rate of change, then it will be linear. You can't have a constant rate of change and not be a straight line. So this option does not work either. It's this last choice. It's not linear. It's not a straight line. And it's not a straight line because it does not have a constant rate of change. Okay, question 10 says Carol is cross-country skiing. The table shows the distance she traveled after various numbers of minutes. What is the rate of change? Oh goodness, how much fun are we going to have here? Look at those fractions. Those are gnarly. Okay, when you're trying to find the rate of change, you are going to be subtracting 2 values from the table on the y side, and you're going to be subtracting 2 values from the table on the x side, and we put the y's over the x's. Now, you can pick any 2 values. You could pick this ordered pair and this one. You could pick these 2 here. You could pick these 2 here. You can pick any 2 you want. We just have to make sure that we're always going in the correct order, so we stay consistent. Now, as I look at these really nasty fractions, I'm focusing on this one and this one because they have a common denominator already, and as ugly as this is about to get in this subtraction in a moment you're going to see, I want to try to make my life a little bit easier, so I'm going to go ahead and pick these 2 ordered pairs. So So I'm focusing on 3, excuse me, and 17/48 and 5 and 35/48. Now, you're going to get a whole lot in this little question right here, but so first I'm going to show you how to calculate rate of change, and then you're actually going to get some good reminders on fraction computation, so adding and subtracting or multiplying and dividing. So I want my y's on top. Remember, the y's are the second coordinate in an ordered pair. The x's are the first. So I'm going to subtract on top. Now, does order matter? It does, as long, and I have to stay consistent. So if I'm going to subtract, if I'm going to do 35/48 minus 17/48, I'm putting that on top. Because I started here with the 35/48, when I subtract on the bottom, I also have to start with 5. 5 minus 3. So on top, we're going to do 35/48 minus 17/48. 35 minus 17, I already have a common denominator, so I just subtract the numerators. That gives me 18/48, all over 5 minus 3 is 2. So now what we have, this is actually called a complex fraction because it has a fraction within a fraction. My numerator here is a fraction, and you aren't going to see, you aren't going to see this answer anywhere in these options. So you're probably thinking, wait a second, how do I get from here to what I actually need? So what we're going to do is a process called multiplying by the reciprocal. Some teach it a little mnemonic to remember: keep, change, flip. It means we're going to keep the first fraction as it is. Remember that fraction bars are actually just division problems. It makes a division problem, so I'm going to change the division now to multiplication, but I have to take the reciprocal of 1/2. Or sorry, the reciprocal of 2, which is 1/2. So I always tell students you can't divide fractions, you have to multiply by the reciprocal. And so there's multiplying by the reciprocal. And now we're going to go ahead and go through and let's do some cross canceling here. 2 goes into 2 once, 2 goes into 18 9 times. Now I can multiply across the top and the bottom. That's 9/48. Let's see, 3 and 8, that's 12. 48 is divisible by 3, and 9 is divisible by 3. So when I reduce this fraction, 9 divided by 3 is 3, 48 divided by 3 is 16. So you get a rate of change of 3/16. That means, in the context of the problem, it's basically a unit rate. It's how much distance is she traveling per minute. Okay, and it wouldn't matter because we're told, are we told that? Various numbers, what's the rate of change? Yeah, so because you're asked to calculate rate of change, we would anticipate this being linear. So any set of ordered pairs from this table should give you 3/16. I just happened to pick these two. Again, I was trying to make my life a little bit easier in that numerator. I'm going to switch to the pen and scroll down a little bit so you can see that the correct answer is 3/16. I hope this helps. If you've got something coming up next week on Wednesday and you can't meet, please let me know. Otherwise, we'll be there. I'll be there. Unfortunately, with the week as short as it is this week and some meetings that I have scheduled, I'm not able to reschedule today. So again, hopefully this video helps, and I will see you next week.